Hello, everyone. Welcome to our deep dive podcast on the latest breakthroughs in text-to-speech technology. Today, we're reviewing the paper IndexTTS2, a breakthrough in emotionally expressive and duration-controlled autoregressive zero-shot text-to-speech. Are you ready to explore the future of TTS?
Absolutely. This paper is from the Artificial Intelligence Platform Department at Bilibili, China, and it introduces IndexTTS2, a model that promises both emotionally expressive and duration-controlled speech synthesis. That's a big leap for TTS applications, especially in areas like video dubbing where timing is crucial.
Right. Let's start by discussing the motivation behind IndexTTS2. Traditional autoregressive TTS models are great at generating natural-sounding speech, but they struggle with precise duration control. Why is that such a problem?
Well, in applications like automated dubbing or synchronized video narration, you need the generated speech to match the timing of the visuals exactly. If the TTS model can't control duration precisely, the audio and video can fall out of sync, which ruins the user experience.
Exactly. Non-autoregressive models have addressed this with duration predictors, but they often sacrifice some naturalness and expressiveness. IndexTTS2 aims to combine the best of both worlds, the naturalness of autoregressive models and the precise duration control of non-autoregressive ones.
That's right. The paper introduces a novel, general, and autoregressive model-friendly method for speech duration control. It supports two generation modes, one where you explicitly specify the number of generated tokens for precise duration, and another where the model generates speech freely, preserving the prosodic features of the input prompt.
That's a clever design. But IndexTTS2 doesn't stop there. It also disentangles emotional expression from speaker identity, allowing independent control over timbre and emotion. This is especially important for zero-shot settings, where the model needs to reconstruct a target timbre and reproduce a specified emotional tone from prompts.
Yes, and to enhance speech clarity in highly emotional expressions, the authors incorporate GPT latent representations and design a three-stage training paradigm. This improves the stability and clarity of the generated speech, which is often a challenge in expressive TTS.
They also introduce a soft instruction mechanism based on text descriptions, fine-tuning Qwen 3 to guide the generation of speech with the desired emotional orientation. This lowers the barrier for emotional control, making it more accessible for users.
Let's break down the architecture of IndexTTS2. The model consists of three core modules: the text-to-semantic T2S module, the semantic-to-MEL S2M module, and the vocoder. Each plays a specific role in the speech synthesis pipeline.
The T2S module is an autoregressive transformer that generates semantic tokens from text, timbre.style prompts, and an optional speech token count. When duration control is needed, a duration encoding mechanism ensures the generated sequence matches the specified length.
For emotional modeling, the T2S module extracts emotional features from style prompts and uses a gradient reversal layer (GRL) to eliminate emotion-irrelevant information during training. This helps disentangle emotion from speaker identity.
The S2M module generates MEL spectrograms using a non-autoregressive architecture. It incorporates GPT latent representations to stabilize speech clarity, especially during intense emotional expressions.
Finally, the vocoder module uses Big V GAN V2 to convert MEL spectrograms into audio waveforms. This ensures high-quality, natural-sounding speech output.
Now let's talk about the key contributions of this work. First, IndexTTS2 is the first autoregressive zero-shot TTS model to combine precise duration control with natural duration generation. The method is scalable to any large-scale autoregressive TTS model.
Second, the model decouples emotional and speaker-related features from the prompts, using a feature fusion strategy to maintain semantic fluency and pronunciation clarity during emotionally rich expressions. They also developed a tool for emotion control using natural language descriptions.
Third, the authors propose an effective training strategy to address the lack of highly expressive speech data. significantly enhancing the emotional expressiveness of zero-shot TTS to state-of-the-art levels.
And finally, they plan to publicly release the code and pre-trained weights, which will facilitate future research and practical applications in the field.
Let's dive deeper into the related work. Current zero-shot large-scale TTS models are either autoregressive or non-autoregressive. Non-autoregressive models excel in duration control, but autoregressive models like XTTS, Voice, and Spark TTS are superior in naturalness and expressiveness.
However, autoregressive models have struggled with precise duration control due to their sequential generation nature. IndexTTS2 addresses this by introducing a duration adaptation scheme that allows precise token number control.
Emotion control in TTS has also been a challenge. Previous methods used emotion labels, natural language descriptions, or reference audio, but they often lacked robustness and control precision. IndexTTS2 enhances emotional expressiveness by adding emotion features and enabling flexible control through natural language or reference audio inputs.
Now, let's look at the proposed method in detail. The T2S module formulates the task as an autoregressive semantic token prediction problem. The input sequence includes speaker attributes, duration control, text embeddings, and semantic tokens extracted from ground truth speech.
Duration control is achieved through a dedicated embedding computed from the target semantic token length. By aligning positional information with target duration information, the system can accurately produce sequences of the desired length.
For emotional control, the model integrates an emotion embedding extracted from style prompts. A GRL is used during training to ensure the emotion embedding captures only emotional and rhythmic attributes, remaining invariant to speaker-specific timbre characteristics.
The training strategy for the T2S module is quite sophisticated. It involves 3 stages: foundational training on the full dataset, refinement of the emotion control module using high-quality emotional speech, and robustness improvement through fine-tuning.
During inference, duration control is achieved by setting the duration embedding, while emotional prosody can be manipulated by providing a desired emotion vector as input.
The S2M module uses flow matching to generate MEL spectrograms. To address pronunciation issues in emotional speech, GPT latent enhancement is introduced. Latent features from the GPT model are fused with semantic features to form an enhanced, context-enriched representation.
This fusion reduces the word error rate in highly expressive speech synthesis, as validated by ablation studies. The S2M module is trained in a single stage, with random fusion of GPT hidden states and semantic tokens to improve pronunciation robustness.
The text-to-emotion T2E module enables natural language emotion control. It defines 7 basic emotions and uses a large language model, DeepSeek-R1, as a teacher to map text input to an emotion probability distribution.
Knowledge distillation is used to transfer this capability to a smaller student model, Qwen 3-1.7b, which is fine-tuned via LoR. The emotion vector is computed as a weighted average over the emotion embedding set and fed into the T2S model.
Let's move on to the experiments. The model was trained on 55,000 hours of data, including both Chinese and English datasets. Emotional data came from 361 speakers, with additional data from the ESD dataset and commercial sources.
Evaluation was conducted on 4 benchmarks: Seed TTS Test-N, Seed TTS Test-We, Libri Speech Test-Clean, and iShell 1. An emotional test set was also constructed with 12 speakers recording sentences for each of the 7 emotional categories.
Objective metrics included word error rate, WEER, speaker similarity, SS, and emotion similarity, ES. Subjective evaluation used a multi-dimensional mean opinion score MOS framework, assessing speaker similarity, prosody, audio quality, and emotional fidelity.
The model was compared with state-of-the-art zero-shot TTS systems, including Mask GCT, F5-TTS, Voice 2, Spark TTS, and the original IndexTTS. 2 ablation experiments were conducted to validate the architectural design and training methodology.
The results are impressive. IndexTTS2 achieves state-of-the-art performance in objective evaluation across most test sets, with only marginal underperformance on iShell 1 relative to the ground truth and IndexTTS.
In subjective evaluation, IndexTTS2 outperforms all baseline models except for a slight underperformance against IndexTTS on seed TTS test N. Removing the GPT latent enhancement improves SS but degrades WER, and the ablated model receives lower subjective scores.
The subjective speaker similarity MOS indicates that, despite a slight drop in SS, the enhanced model is perceived by human listeners as more similar to the target speaker. This confirms the importance of GPT latents in enhancing semantic clarity.
For emotional performance, IndexTTS2 achieves the highest scores across all 4 subjective evaluation dimensions, demonstrating superior emotional rendering capabilities. It also shows leading performance in SS and ES compared to 5 baseline models.
The GPT latent enhancement in the S2M module plays a crucial role in maintaining speech clarity and articulation under high emotional expressiveness. Removing the 3-stage training strategy severely degrades emotional expressiveness.
The T2E module's effectiveness for natural language emotion control was evaluated using a constructed test set. IndexTTS2 outperformed CausyVoice 2 in all aspects, demonstrating superior natural language-based emotion control capabilities.
Duration control accuracy was evaluated on seed TTS test-we and test N, using 5 experimental setups with different duration scalings. IndexTTS2 achieved minimal token number error rates, demonstrating precise control over speech synthesis timing.
Speech quality under duration control was assessed by comparing WER. IndexTTS2 matches F5-TTS on test N and significantly outperforms mask-GCT. On test-we, it surpasses F5-TTS and mask-GCT, with only a marginal drop in performance under scaled durations.
Prosodic advantages of autoregressive modeling under fixed duration control were also demonstrated. IndexTTS2 achieves superior prosody and speech quality compared to non-autoregressive TTS systems.
In conclusion, IndexTTS2 is a zero-shot speech synthesis system that enhances duration modeling, emotional expressiveness, and phonetic clarity via an innovative autoregressive architecture with optimized training.
Featuring unique duration control for precise timing and a mechanism to decouple emotional and speaker features, IndexTTS2 facilitates emotion-specific speech generation from reference audio.
An LLM-driven module matches emotion vectors for language-based modulation, ensuring natural expression. Combined with specialized training and data augmentation strategies, the model achieves state-of-the-art performance in high expressive emotional restoration.
Efficient in zero-shot settings, IndexTTS2 produces expressive speech with controllable duration and emotions, advancing voice solutions for animated dubbing and video narration, while pushing the boundaries of speech synthesis technology.
That's a comprehensive review of IndexTTS2. The model sets a new standard for emotionally expressive and duration-controlled TTS, with practical applications in dubbing, narration, and beyond.
If you're interested in exploring the audio samples or the code, the authors have made them available online. This openness will surely accelerate further research and innovation in the field.
Absolutely. The combination of technical innovation, practical utility, and open access makes IndexTTS2 a landmark contribution to the TTS community.
To summarize, IndexTTS2 introduces a novel approach to duration control and emotional expressiveness in autoregressive zero-shot TTS, achieving state-of-the-art results and paving the way for more natural and controllable speech synthesis.
Thank you for joining us on this deep dive podcast.